All right, so hopefully your dot plot looks something like mine. Now, notice, you can kind of see, to the best of my abilities, I tried to make my dot plot as even as possible. So when you are going to do dot plots, which you are going to get graded on, you're going to want to make them as symmetrical as possible. Okay, now notice for your data here, it kind of goes up and then it comes back down. It almost makes like a bell shape, right, with my data, a bell kind of shape. So it's small to large and then back down to small. Kind of, yeah. So this is my dot plot. There's my first one. You've graphed your first data in the first type. I think I'm gonna have to move you guys in a second. Then I need you to act like young adults. Okay, letter B is a histogram of the data. Does anybody in here know what a histogram looks like?
And then isn't that like a bar graph?
It's kind of like a bar graph, yep. So it's essentially has the graph of the data is in bars, but instead of me plotting each one individually, what you do is you count how many of each type that you have. So on the x-axis, we're still going to put the same thing. We're still going to put our time in minutes. That's on my x-axis. And notice I'm always labeling my axes every time. On the y-axis, the up and down, I'm going to put my frequency, or you can call it the count. It's how many you have of each one. So you can call it frequency or you can call it count. Frequency count. Now, I have to draw my data right from the beginning to the very end. Now, you can count by whatever you want to count by. You can count by 2s, you can count by 4s, you can count by 5s, you can count by 10s. Doesn't really matter as long as it fits your data. So, since most of my data is between 50 and 70, should I count by millions? Is that a good choice?
Not really.
Probably not. What do you think I should count by?
2, 5.
Count by 5s, you can count by 10s, yes, but you do have to start at 0. So what would you like to count by?
5.
5, 10, 15, 20.
15.
That's not enough. We gotta do
Yep, so if you go by 5s, it's not going to be enough, right? So we'll go by 10s. Okay, so we'll do 10, 20, all the way across. Now these are called the increments. It's how much you're counting by. So we're counting by 10s. 40, 50. Okay, don't need to go past 100 minutes. Now, frequency means how many of each you have. So if I'm counting by 10s, I want to say, okay, how many numbers do I have that go from 50 to 60? How many do I have? So if you come back up here to your data, we counted by 10s. How many numbers are between 50 and 60?
10.
They don't include the 60. So it has to be 50, essentially up to 59. It can't include the 60.
5.
1, 2, 3, 4, 5,
6.
6 of them. So 6 numbers are within the 50 to 59 range. 6 of them. How many are within the 60 to 69 range?
You said what?
Essentially right before the 70.
9.
9 of them, okay? And then my 70s, I've got 2. So the highest number I need to get to is 9. So for my frequency, the highest number I need to get to is 9. What should I count by?
3.
Well, I could count by 3s, but the problem is going to be one of the numbers is a 2. So it's going to be hard to graph that one. Yeah, so counting by 1s is probably a better choice. So 1, 2, and all the way up. Now, does this mean this is exactly how your histogram has to look? No. If you wanted to count by 2s, that's fine. It just might not be as exact as if you were to count by 1s. Okay, so when we do our histogram, it's essentially bar charts, like a bar chart kind of data, and they touch each other. So from 50 to 60, right, all the numbers that start with a 5, we have 1, 2, 3, 4, 5. We have 6 of them. So I'm going to go all the way up to 6 at the 50, and then I'm going to go over and make a bar. So from 50 to 60, there are 6 within there. I'll zoom in a little bit here. From 50, so all the numbers that start with a 5, there are 6 of them. How many numbers did we say we have that start with a 6? 5. 6.
5. No,
Whoa.
6, it was, wait, I'm sorry.
All the numbers that start with a 6.
Oh.
All the numbers over here that start with a 6.
9.
9 of them. Good. So from 60 over, I'm going to go all the way up to 9. And then how many numbers did we have that start with the 7 in the 70 range?
2.
2. So it'll go up to 2 and do the same thing. So you have now drawn a histogram. You've now constructed a histogram. So we've just used the same data. We've created a dot plot and we've created a histogram. Of those two, which one do you think is easier to read?
Dot plot.
Probably the dot plot. Yeah, it's easier, but I think the issue is going to be if I gave you like 100 points, would you want a dot plot or would you want a histogram?
Dot
Dot
plot.
plot.
You would want to draw 100 dots. What if I gave you 500 dots, 500 pieces of data? You would want to do it. That's a lot of dots to have to draw. So if there's only a few, this is a better choice. If there's a lot of data, this histogram is a better choice. Okay, so you've now just created 2 different charts based on the same data. We are now, part C, going to create a 5-number summary of our data. And I have a feeling you've probably done this before. A 5-number summary talks about the minimum, the maximum, the median, the mean, and the range. I think those are all probably words you've heard before. Maybe.
Yeah.
Okay, now, when you do your 5-number summary, your data has to be in order from least to greatest. Okay, so it has to be in order from least to greatest. Okay, now here's what I'm going to do. I'm going to take this data up here. It is already in order for you. I tried to be nice for the first one. I would like you to copy that data in order from least to greatest in a straight line. One straight line. So take a second, copy that data in one straight line. Wherever you got some space. One. Don't write too big. 1, 2, 3, 4. Oops. 3, 4, 5. Yikes. Just made it. Yep. Woo. And then once you've rewritten them, count them, make sure you have 17. How do I have more than 17? What did I do? 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oops, I got one too many. That's fine. Okay. Yep, count and make sure. Mr. Master just made a mistake, so make sure you didn't make a mistake. $70. Okay. Now, our 5-number summary, we start by putting our minimum value first. So minimum means
50.
least. Yes, so the smallest number we have is 50 minutes. So my minimum is 50. What is your maximum value you have?
70.
70, great. So you've already got 2 of the 5 numbers. Now, median means what? In the middle. How can you figure out what's in the middle? What should you do?
Oh, okay, so you,
Go for it. What did you say?
okay, so you take one finger on each side
Mhm.
and then you go up.
Exactly. So take one finger on each side and we're just going to count. You can cross them out. That's not a bad choice, but here's the issue. You're going to have to do mean in a second. So I don't like crossing things out because then you can't see them when you go to use the number again. So I would just go for your fingers. Okay. So go one by one. Everybody do it. See what you get for your median. See if you get the same answer.
And the best one wasn't the easy one.
Yeah, 9,
Yeah.
15.
Yeah, what's the low? 50, 60.
Okay.
No. He's coming on.
Right. So you should have a number right in the middle, correct? A number right in the middle. Circle your number 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 in the middle. It's the third 60.
Oh, I put it on the box.
That's okay. That's fine. All right. So your median, your middle amount of time is 60 minutes. Now, your lower quartile and your upper quartile. Have you heard those words before? Some of us have, some of us haven't.
Lower and upper.
Lower, you might have also heard it as this is also called quartile 1. And the upper quartile is called quartile 3, Q3. No, it's gonna be easy. Don't worry. I got you. It'll be easy. Now, quartile 1, here's what that means. That means go to the lower half of your data. So here's the halfway point right here. This is halfway. What I'm going to do is I'm going to find the number in the middle of the lower half.
You find 1/4 or like half and half?
So yeah, essentially it's what's the halfway? So you don't want to include the
It's 55.
60. So now hold on a second, right? Because as you do it, what's going to happen? No. There's no middle number, is there? It's between 55 and 55, but what number is between 55 and 55?
54, so that's
Whoa.
55.
It's just 55.
Wait, what? You just said what number is between?
55 and 55.
Oh.
It's itself.
No, I heard that wrong.
You're okay. So your quartile 1 is this little spot right here. I want you to make a little circle it or do something kind of like Mr. Master did here. This is your quartile 1. So your lower quartile number is 55. We're going to do the same thing with quartile 3, which is your upper quartile. So again, you've got to find the middle number in your upper quartile. So it's going to be the same thing. Between 65 and 65 is what?
65.
65. So your upper quartile is 65. So this tells you the least amount of time, the median amount of time, and the most amount of time that it takes scholars at Largo High School to get ready in the morning. You've just completed, that's the 5-number summary right there. Now, the next part is right over here. The mean and the IQR, interquartile range. Let's do this one first. What does the word range mean?
Distance.
Yeah, the distance between two things. So if I'm talking about the range of my quartiles, that means what's the smallest that my quartile is, and what's the biggest that my quartile is, and what's the difference between the two.
50, 70, 20.
Well, so we're talking just about the ones that have the Qs, the quartiles. What is your larger quartile?
65.
What is your lower quartile?
55.
55. So what is the distance between those two? You just subtract. It's 10. Exactly. So you just figured out your range. So your range is 65 minus 55. Good. We're going to skip standard deviation. We'll do that another time because that's an online one. But now the last part we're going to do, what is mean? What does mean mean?
What is the whole thing?
And then what's your average?
It's the average of your numbers. Good. Average.
But then why couldn't they have just said average?
Because in mathematics, we use the specific math terminology when we're talking about things. You can say average, and that might mean something different to someone else. They might make a guesstimate of it, whereas if you use the word mean, that means you actually have to calculate it. Good question. Okay, how do I figure out the mean? Mikey, what do you think? Why divide by 17?
That's
There's
the
17
total
scholars.
numbers.
Oh my gosh, Mikey, I would appreciate if you answer the question because you raise your hand. That's the amount of data points that you have. Exactly. So you're going to take a second right now. You're going to do this on your own. You're going to take, bless you, the total sum, and you're going to divide it by the number of data points. So use that calculator. Go slowly. We'll see if we get the same answer. This is where you can start crossing them off if you want. Total sum divided by the number of data points.
Is it a decimal?
No.
Oh, I got 60. Yeah. It was a lot better than I thought because I put some wrong numbers in.
So my suggestion is for the average, I would cross them off as you're doing the averages. So as you're adding them together, cross them off, and add them all first before you try to divide anything. Add everything together first on top. So you tell me, what number did you get when you added them all together on the top? Jada, what'd you get?
Can I do that? Can I use my phone calculator because it's like too small. Then I get
I got it.
Mine's
Too small.
What?
Too small.
1020.
Too small.
10
what? 1020.
Yeah.
Yikes. Try it again. Everybody try it again until you get 1020 at the top. I'm dead serious. I mean, I'll try it again, but the chance that Mr. Massa was wrong is slim to none because,
I'm not doing
Jesus.
it.
You have to do it again. That's the whole point of this.
I did, but then I divided by 17. I got like.
What?
Zero. I got 960.
I got 962.
Yeah.
Now I got 100.
Is that right? Yeah.
No, not 100. I mean,
Bro, I got 960.
I got 9.
You're supposed to get 1020 at the top.
Cool.
Okay, now let me tell you this. If you're using the calculator and you just push plus, 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 and you never push the equals button at the top to get your number, that's when you're going to get something wrong. Yes, so the calculators are kind of finicky. If you're going to add everything together, you have to push the equal sign to get the number at the top before you divide. Because if you push divide and you don't push that equal sign, your calculator does not know order of operations. And it will do something different. Yes. What'd you get? 60. 60. So your mean is 60. Good. Good, 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 good. All right, questions so far? All right, we got one more graph or whatever you want to call it to draw. Well, we'll see. We've got one more graph to draw. Same data, still hasn't changed, same data. Okay, we're going to draw a graph over here. Now, we're going to create a box plot. Have you done a box plot before? I hope
Yes,
so.
I have.
Okay, good.
Sadly, yes.
Well, that's not sad. That's a good thing. What is on the x-axis right here?
Time in minutes.
Time in minutes. Good. Let me make sure I'm very clear. If you do not graph, if you do not label the x-axis, you will get it wrong. I will mark it wrong. You have to have it labeled every time. Because it's a box plot, so it's not on like a regular graph this time. All right, so here's how we're going to draw the box plot. Everybody watch, because I do not want you to get messed up. And I'm also going to show you a little trick so that your box plot looks pretty. Looks pretty. Okay, ready? Here's the trick. All 5 of these numbers right here are going to be a vertical line on your graph. A vertical line on your graph, and they're going to be the same length of a vertical line. So here's what I mean. My minimum is at 50. So you're going to come to 50. You're going to draw a vertical line right above it. Then you're going to come to the lower quartile, which is 55. Here's 55. Again, I'm going to draw a vertical line. Same distance, right? Same length. I'm going to do the same for my median of 60. Yep, you're doing it with me? Yep, you can start doing it now. Your upper quartile is 65. And your maximum is 70. Okay, a lot of vertical lines, as even as you can make them. It does not have to be perfect. I didn't give you a ruler, so it's not going to be perfect, and that's okay.
Yeah, you gotta use those calculators.
Yeah, I can use the edge of the calculator if you want.
Oh, I thought it was.
You can. I'll have rulers for you tomorrow. I just forgot to grab them out. We don't really know yet. I mean, that was what was told was that the hope was. Well, I don't know. Yeah, because I'd rather do this stuff on the computer than in my hand.
Then you can make straight lines.
Also, do you notice we have
I don't know on like a personal case by case basis. Typically, if you are a freshman, you're in here all year. If you're a sophomore, you're in here all year. If you're a junior, you're likely only in here for the first semester. Okay, now here's how the rest of this gets connected. The 3 lines in the center are your box. So the 3 lines in the center you are going to connect and make a box. Yeah, you've probably seen these before. These 2 pieces, okay, boys, I'm not going to ask you to stop talking again. These 2 pieces are called the whiskers. So they're like the edges of the box, and they just get connected with a straight line.
Oh, is this
The whisker plot.
yeah, but then you told us.
This is.
Box and
No.
called a box plot or a box and whisker plot, depending on what you call it. Now we're going to just label the pieces. So this line right here is your minimum. Thank you. Okay. This line right here is your minimum. What is this line over here? Yep. Q1 or lower quartile. I always put Q1 personally. Just left to right. This one over here is your median. This one over here is your Q3. And this one over here is your max. Good. Right, so I think box and whisker plots are easier if you make them all vertical lines first and connect them afterwards. Because I think if you try to connect them as you go, people usually get really confused. Yeah. Okay. So let's finish up with this bottom part. We're going to take a look at the data. We're going to answer some questions about it. So you now have the data for you in 3 different ways. It's the same data. You've got a dot plot, you've got a histogram, and you've got a box and whisker plot. So now we're going to answer some questions. Number 1, does your data have any outliers? If so, what are they? What does the word outlier mean?
It's not.
This number that's what? Not the same as the others? What do you mean?
Like
It's out of
Like
place.
30.
Like it's like
30,
5%.
and the rest of our numbers are like 60.
So
Right.
no, it is not.
Right, so an outlier would be something that's way off of the rest of your data. So if most of your data is between, ours is all between 50 and 70. If we had a number that was like 2, only takes them 2 minutes in the morning to get ready, that would be an outlier. It's really, really, really far away.
He's a flat outlier.
What?
And
That
also
would be-
give a flat outlier.
And here's how you can see the outlier. You look for the whiskers. If you have a really, really, really long whisker and your boxes are all together, then you've got an outlier. But my whiskers look to be about the same length as everything else, so I don't have any outliers. So your answer there is no. No outliers. Okay. Looking at your diagrams, what value is the majority of your data located? So at what number do you have most of your data?
60.
60. Yeah, that's the one that repeats the most often. So it's 60 minutes. What else could we call that if it repeats the most often?
Pattern.
Mean, median, and
Mode.
mode. Mode. Have you heard that one before?
Do we have to follow that?
Yes. So mode just means the one that is the most repetitive. So it's what most of the people answered. Okay. Last 2. Does your median, mean, or both best represent the value where the majority is located? So most of our data is located at the 60. What was our mean? What?
60.
Oh, our mean was 60. What was our median? Yeah, it's also 60. So is our data located at the mean, the median, or both?
Oh.
It's at both. Yep, right in the middle, exactly. Okay, last part. What type of distribution, we're not done. What type of distribution does your data have?
Symmetric.
How do you know?
Because they're all alike.
Because it's all symmetrical.
What does symmetrical mean?
So like if
They're
there was
all
like a
the
2 in it,
same
it
size.
wouldn't be symmetrical because all the numbers are alike.
All the numbers are alike, yes?
They look, they're both on the same side.
Both on the same side. So is symmetrical data looks like a bell. It looks like a perfect bell. And that's exactly what we have right here, a perfect bell. So this is symmetric data. Symmetric. We have a couple more minutes. All right, so real quick, while you're cleaning up, just listen for a moment. I need everyone to stop talking and just listen. Couple quick things. If you did not turn in your multi-step equation half sheet on Canvas and you were here for that, you got to turn it in. It's going to close tomorrow, but attempt, I'll look later. Attempt to submit it. Second thing, everybody needs to get their guardian, parent, adult at home to take that survey. If they have not taken that survey, you better go home with them today and take that survey. Okay? Other than that, you don't have any other homework. Do not lose that packet. I'm not printing you another one. Don't lose that packet. I'm not printing you another one.
I sent it in yesterday. It did like that thing when you submit it. It's like.
Okay, you can put it in the bin right over there. If you want to leave your binders here, you can leave them here.
You got like dots everywhere.